Hey guys, how you doing? Welcome to Venus Neuron, your go-to resource for medical school success. And in this video, we're going to talk about laws of dilute solutions. We're going to talk about colligative or collective properties and what they are. We're going to talk about Raoult's law and so on. Now, let's get started. So, what's a colligative property? Several important properties of solutions depend on the number of solute particles in solution and not on the nature of the solute particles. So basically, they are the physical properties of a solution that depend only on the concentration of the solute particles in a given quantity of solute, not on the chemical identity of the particles. Now, these properties include vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Now, before we begin, let's talk about Raoult's law. If the solute is not volatile, we talk about Raoult's law and the rest of them. So Raoult's law states that the partial pressure of a solvent over a solution is given by the vapor pressure of the pure solvent times the mole fraction of the solvent in the solution, like this. Now, what is a volatile solute? A volatile solute refers to a solute that can easily evaporate or vaporize into the gas phase at relatively low temperatures. In other words, it is a substance that has a high vapor pressure at a given temperature, meaning it readily transitions from a liquid or solid state into a gas. A volatile solute has high vapor pressure, which means that at any given temperature, a significant amount of the substance can escape into the gas phase. They also have evaporation tendency, which means they tend to evaporate quickly when exposed to the air, as they do not require much energy to overcome the intermolecular forces holding the particles together. They also have low boiling point, as they require less heat to transition from the liquid to the gas phase. Some examples of volatile solutes are alcohols such as ethanol, acetone, and volatile organic compounds include substances like benzene, toluene, formaldehyde, which can evaporate easily into the air. Well, now you know what a volatile substance is, and so you know what a not volatile substance is. Okay? Now let's get back to the colligative properties of dilute solutions. First of them that we're going to talk about is boiling point elevation. Basically, addition of a non-volatile solute to a solvent makes the boiling point of the solution higher than that of the solvent alone. As you can see here, this is the formula that you can use in related questions. And as you can see here, the change of temperature is proportional to the molality. So why don't we use molarity instead of molality? Because if the temperature changes, there will also be a change in volume as well. So we have to use something which is not affected by change of temperature. The next property is freezing point depression. So it means that addition of a non-volatile solute to a solvent makes the freezing point of the solution lower than that of the solvent alone. Next one is vapor pressure lowering. It means that addition of a non-volatile solute to a solvent makes the vapor pressure of the solution lower than that of the solvent alone. And lastly, we have osmotic pressure. Now, first let me tell you what is osmosis, and then we can go for osmotic pressure. Osmosis is the net movement of solvent molecules through a semi-permeable membrane from a pure solvent or from a dilute solution to a more concentrated solution. Okay. The osmotic pressure of a solution is the pressure required to stop osmosis from pure solvent into the solution. Now we can have semi-permeable membrane, could be either osmotic or dialysate. In the osmotic type, only the solvent molecules can go through it. But in dialysate type, also ions can go through it, but not colloid molecules. It has larger pores, and another important thing about it is that ions are in water gauge. Now you can see the formula to calculate it, but as you can see here, we're using molarity, so why not molality? Can you guess the reason? Nice, because the temperature is constant, so there will be no change in volume, and working with molarity is way easier. Now, you might have heard about osmolarity. Do you know what osmolarity is? It's equal to molarity multiplied by I, where I is the number of particles from the dissociation of one formula unit of solute. It's basically the number of particles in the original solution. Now, about osmotic pressure, we're going to talk about the concept of hypotonic, hypertonic, and isotonic solutions. When we say something in hypo, it's less than normal. When you say hyper, it's more than normal. And iso, it's like the same. Okay, so when we say hypotonic solution, they are solutions with an osmotic pressure lower than that in cells. So they cause cells to hemolyze or burst. When we have hypertonic solution, it means solutions with an osmotic pressure higher than that in the cells. It causes cells to crenate or shrink. And in isotonic solutions, the osmotic pressure is equal to that in cells, so it has no effect on cell size. Now, this is going to be a little additional point, like what is boiling point, what is freezing point, what is vapor pressure to begin with, and so on. You might also want to know how Raoult's law works. Now let's talk about these. So boiling point is the temperature at which the vapor pressure of the liquid equals the pressure surrounding the liquid and the liquid changes into a vapor. And freezing point is the temperature at which a liquid freezes. For water, it's 0. Good job. Now you might want to know about what is vapor pressure. Vapor pressure is the pressure exerted by a vapor that is in dynamic equilibrium with its liquid in a closed system. It is dependent on temperature. Okay, so now you get the vapor pressure lowering better. The solution that contains a non-volatile, meaning not easily vaporized, solute always has a lower vapor pressure than the pure solvent. Okay, now you get it better. Now let's talk about how Raoult's law works. So it basically explains that when a non-volatile solute is dissolved in a solvent, the vapor pressure of the solvent is lowered. You know till this part. So why does this happen? It happens because the solute reduces the number of solvent molecules at the surface that can escape into the gas phase. The degree of vapor pressure lowering is proportional to the mole fraction of the solute in the solution. And so this will not work due to interaction between solvent and solute. Okay? Now this was all for today's video. In the next video, we're going to talk about chemical equilibrium, Le Chatelier principle, and the next one it's acid base and so on. So if you have any recommendations for new topics or if you have any questions, let me know in the comment section. Don't forget to like if this video helped you and subscribe for more videos. And as I always say, stay curious, keep learning, and I'll see you in the next video.